For any right angle triangle, there are six trigonometric ratios. These ratios relate the lengths of the sides of the triangle with the angle side in sides. You can use these ratios to solve missing information in the triangle, but more on that in later sessions. Okay. So if we have a triangle, we have six trigonometric ratios that relate the sides of the triangles with the angles of the triangle. The base of the triangle is called adjacent. The perpendicular of the triangle is called opposite, and the slant line is called hypotenuse. So these are the three basics types of the triangles. Okay. So sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. So reciprocal trigonometric ratios. There are three additional trigonometric ratios that will introduce you this year. The reciprocals of sine, cosine, and tangent. Their name is cosecant, secant, and cotangent. Cosecant is the reciprocal of sine theta. Hypotenuse over opposite means h over o, means sine theta is over h, so it would be h over o. Secant theta is 1 over cos theta. Hypotenuse over adjacent means h over a. Cot theta is 1 over tan theta means a over o. Okay. Special right and triangle relationships. Last class we focused on angles in the circle that are multiples of 30, 45 and 60. Today we will examine that special right triangles that contain these angles. So if a triangle has 190-degree and 245-degree angles, or a triangle have 360-degree angles, 190, 160 or 130-degree angle. So the ratio of the sides of the triangle would be 1, 1 square root 2. If it is 45, 45, 90 triangle. If it is 30, 60, 90 triangle, then the ratio would be 1, 2 square root 3. And for here, it would be 2, 2 and 2. Consider an angle of 30 degree drawn in the standard position as shown in the figure. Create a right triangle by dropping a vertical line from the terminal arm of the angle down to the x-axis. This is one for the special triangles. So if we will drop one arm from here, we will get a triangle. Label each side of the triangle showing your knowledge using knowledge for 30, 60, 90 triangles. So for 30, 60, 90, it would be 1, 2 and square root 3. Sine 30 would be equal to, sine theta is equal to h over o. So sine theta is equal to h over o, which is equal to 1 by 2. Cos theta is equal to h over h. Sine theta is equal to o over h. Cos theta is equal to a over h. So a is square root 3 by 2, and tan 30 would be equal to o over a. So what is o? Opposite 1 and adjacent square root 3. Okay. Finally, reminders reciprocal ratios. So cosecant 30 would be equal to cos opposite of secant. Sine 30 is cosecant. 1 over 2, so it would be 2. Cos opposite is secant, so it would be 2 over square root 3. Tan is cot, so it would be square root 3. Create a right triangle and label each side using So you can see that sine 45 and cos 45 has the same value. Okay, draw an angle of 150 degree in the standard position. Create a right angle by dropping a vertical line from the terminal arm to the x-axis. The angle we formed is, it's 150 degrees, so it was total 180 degrees, so it would be 30 degrees. This is called the reference angle of 150 degree. Label each side of triangle using 30, 60, 90 ratio. It would be 1, 2 and square root negative of square root 3. So using the reference angle, we can evaluate sine 150. Sine 150 is equal to sine 30, and sine 30 is equal to 1 by 2. Cos 150 is equal to minus cos 30, which is equal to minus square root 3 by 2. Tan would be equal to minus tan 30 minus 1 over square root of 3. Cos 150 is equal to cosecant would be the opposite, secant would be the opposite, and it would be the opposite. Reference angles. Whenever you draw an angle in the standard position, it will have a reference angle denoted by theta r. The reference angle is formed by the terminal side of the angle and the x-axis. Reference angles are always positive and always acute less than 90 degree. Okay, so if this is an angle, this is called the reference angle. If this is an angle, then reference angle is denoted by this with the, this is the reference angle and this is the reference angle. Reference angle are always less than 90 degrees and they are drawn with the x-axis. Draw each angle theta in standard position. So we can draw 135 degrees. And what will be the reference angle? The remaining one. This 45 degrees will be the theta r. Similarly, if we draw 5 pi by 3, it's 5 pi by 3, and this one is pi by 3, which is theta r. We can use reference angles and reference triangles to find the trigonometric ratios of an angle in the standard position, no matter what quadrant the terminal arm lies. Evaluate 315 degrees. Sine 315 will be equal to negative of sine 45, and we know that sine 45 is equal to 1 over square root 2. Cot 4 by 3, 4 pi by 3. Find the reciprocal of each of the following. Fill in the missing sides of the special triangles below and use the table to complete them. So sine theta is equal to, some people have perpendicular over hypotenuse 1 over square root 2. Use reference triangles to evaluate the following cos 135. Okay, so we are done with it. Thank you so much. For example, this is 1 minus 135, so we will go like this. Can mark the angles for you. In this way, we will get the triangles in each of the following. Thank you so much. Take care. Allah Hafiz.